Okay guys, hello and welcome to the Introduction to Alias and NURBs Surfacing tutorial. Um, Today we're actually not going to be modeling anything, and for good reason. As a matter of fact, I would prefer if you don't even open up the software right now. You can if you want. I wouldn't really advise that. Simply because I want to explain some basic concepts to you today, and I want to go over the fundamentals of modeling within Alias and NURB surfacing and what it's built upon. And if you're in the software and you're clicking around as I'm clicking around, I'm a little worried that you're not going to really some of these facts and pieces of information won't sink in as well. So with that being said, I'd like to start with one basic rule of thumb with Alias and NURB surfacing, okay? Because there are a lot of tutorials out there that are floating around that you see somebody modeling something, they'll say that you see somebody modeling something and you'll see them clicking around. You don't know what it is that they're clicking. You don't know what function they're turning on, and you don't know, they're just clicking around and you're just expected to follow along. Sometimes they're narrating, sometimes they're not, sometimes they're speaking a foreign language. So really, the way the information is the information that's floating out there is not very well organized, and it doesn't really have a solid foundation or a solid basis to it. So that's what I hope to drive home to you guys. I want you guys to work with Alias and NURBs with a solid foundation. Okay, so that's number one. Now, so the rule of thumb of Alias. Okay, if you were to summarize, okay, everything that goes into NURBs surfacing, okay, if you were to summarize the two fundamental aspects that we have of Alias and NURBs surfacing, it would be the curve and the surface. Okay, that's number one. Now number two, okay, frequently a lot of Alias modelers like to refer to themselves as Alias modelers, okay? But that's really only half true. And the reason why I say that is because, yes, we work with Alias. Yes, we're working with, functions within Alias. But truthfully, what we're actually working with is NURBs math, NURBs data, okay? So, and we're creating a finished product that's built off of NURBs math and the harmony that technique affords us. Okay, so when someone says that they use the Alias modeling technique, what they really mean is they're using the NURBs modeling technique, because Alias is the brand, but NURBs is the product. Okay, and that's really key. So one question you might be asking yourself is, why Alias? Cadia has some surfacing tools. I know of this other software package that has surfacing tools. Why Alias? The very simple reason for that is that Alias gives us the highest, or I would say, the most functionality when it comes to manipulating surface data. Okay, it's not that other software packages, other more, I would say, other parametric or dimension-based software packages don't have surfacing tools. But Alias is really meant for that. It's really driven in that direction. It's really meant for manipulating surface data, topology, evaluating your work, evaluating, the way light reflects off of a surface. It's meant for that. It's really meant to assess the form in which we create a 3D object. And a direct opposite of that, a direct opposite of a parametric modeler or a dimension-based modeler or surface-based, NURBs-based modeler like Alias would be something that's built on, that works with polygons. Okay, and polygons are very popular because, of the entertainment industry and CG and stuff like that. And that's a different category of 3D altogether. Okay, so and we're not going to be working with polygons. We're working with surfaces and NURBs today. Okay, so going back to what I was originally saying earlier, we have the number one rule of thumb for Alias is that we have curves and we have surfaces. Okay, and I'm going to just quickly bring up the software for you guys, and you don't have to boot up the software right now. I don't really want you to. Just want you to watch, want you to listen, and things will just come together. At first, things are going to seem a little abstract, and I know many of you are very eager. You want to model a car, or a bicycle, or a pair of headphones, a motorcycle, whatever. But I'm telling you right now that if you just watch a tutorial, a modeling tutorial that has no context, it's just taken out of context, you're gonna learn more slowly. Okay, if you understand what a curve is, what a surface is, the aspects of the two of them, how they relate to each other, you're gonna learn faster, you're gonna model faster, your models are gonna get better faster. Okay, and that's what you want. Okay, we want results. So, and take it from me, because speaking from personal experience, it took me a while to learn the software. I won't give you specifics, but it took me a while to learn. Okay, and I made plenty of mistakes along the way. So, my mistakes are your profit. Okay, so that's the best way I could say. My mistakes is your profit. Okay, so without further ado, let's get started. Okay guys, so here we are in the workspace, the main modeling window, and I'm not going to go over all of the tools here. Okay, when you open up Alias for the first time, your view is going to be similar to this. You probably won't have, you won't have these two windows popped up over here. It would be weird if you did. That's because this is kind of like my personal touch, how I like to work. You're going to have a similar view to this. Okay, over on the left, you're going to have a bunch of drop-down menus. Okay, and all this stuff is key. Now, I don't want you to get intimidated. I don't want you to to be, like I said, intimidated by all these buttons and these functions, because I will tell you right now, okay, I will tell you right now that all the functions that you see in the software, all those buttons and those shorthand script things, really 80% of them are just different ways of manipulating NURBs, curves, and surfaces. Okay, that's it. Okay, they're just accelerated ways of manipulating this data. Okay, and getting it to do things the way you want them to, because the truth is that you can actually make a very clean, professional looking model with really only a half dozen functions. So long as you're able to edit curves and their CVs, and you're able to evaluate their construction and their relationship to each other, both CVs and surfaces and curves. So long as you're able to evaluate that and assess the model once it's complete, you're there. You've done it. So don't let that scare you so much, or don't let that scare you at all, as a matter of fact. So we're back in the software, and here we could see we have all these different buttons laid out and stuff like that. And what I'm going to do is I want to show you the intricate workings of the curve, okay? Because remember, going back to what I was saying earlier, I mentioned that the rule of thumb in Alias is that, the general rule of thumb, number one is the curve, and number two is the surface, okay? So that's what we're going to do. We're going to focus on the curve, and then later on we're going to focus on the surface. But right now we're going to focus on the curve, okay? What I'm going to do is I'm going to adjust my viewing pane here, and this is called the view cube. And there's a little arrow over here. I'm going to just click this arrow, okay? And we see we have different views here from the drop-down menu, all right? Most people work in the perspective view, so that's fine. I don't, okay? And the reason why I don't is because when you work with perspective, you run the risk of the camera affecting the proportions of your model, okay? You run the risk of the camera of lens distortion, okay? And when that happens, it can affect, if you're sensitive to proportions and you're sensitive to shapes and stuff like that, it can affect the aesthetic quality of your model, okay? And when I work, I like to make sure that I like to have a very honest view of what it is that I'm looking at. So I work in the orthographic view, okay? So I'm just going to go ahead, I'm going to click orthographic. And now what's going to happen is we're going to have more, I would say more of an engineering more engineering angles, views, okay, when it comes to working with the model. It's going to be truer to form, okay? And so what I'm going to do is I'm going to click left, okay, and it's going to lock us to the left view orthographically. Okay, we know we're orthographic because it says orthographic and the view cube is green. Okay, and I'm going to swing my cursor over here and I'm just going to click CV curve. Okay, now if you double click a tool in Alias, you get some options and stuff. Okay, you get some information, and this, don't worry about this. For right now it doesn't matter. But that's the general rule of thumb. You double click on something and you get some information, and you can edit parameters and stuff like that, and get it to do you can get the tool to do what it is that you need to do. Okay, but for right now I want to talk about curves, okay, and I want to talk about why the data of a curve matters. Okay, so what I'm going to do is I'm going to click the curve button, and I'm going to click once, and I'm going to click anywhere twice, just like that. Okay, I've created my first curve. Okay, and mind you, curves in models, now if you're wondering what this is a clutch menu, and I'm popping this up with Control and Shift held down, and I'm pressing a mouse button. This is the left mouse button, the middle mouse button, and the right mouse button. Okay, and depending on what you press on the mouse, it pops up something, it pops up a menu. Okay, and this allows you to select something quickly, as opposed to physically dragging your mouse over and and selecting, excuse me, selecting a curve or something, pick. It says pick, as opposed to swinging your as opposed to swinging your cursor over, you can just hit, a clutch menu, and you can, pick a CV, pick a hull, a surface, curve, object, fancy stuff over here. It's a lot faster as you're modeling to just, it saves time that way. And as you get better, you're going to be grateful that you can just, quickly swap tools and select things from the clutch menu. But anyway, going back to our initial curve, and what I'm going to do is I'm going to hit Control Shift, left mouse button, pick curve, and I'm just going to drag a box over this curve. And what I'm going to do is I'm going to assess this curve. Okay? Now you don't have to follow along with me in the software. I'm not expecting you to. I just want this to I want you to absorb some points that I'm going to be making here. Okay? No pun intended. But I just want you to absorb some information right now. So we have a curve selected, and what I'm going to do is I'm going to pay attention to, I'm going to look in this area here, okay? And this area gives us some information about an object that we've selected, okay? We see here we have one picked curve, and it's called curve number 2. And this is some of the information about the curve. This is the mathematical information about the curve, okay? We see the word degree. We see the word spans. What is a degree and what's spans, okay? Well, simply put, a degree is the level of control that you have over either your curves, or surfaces, okay? And a span, the best way I can describe a span is essentially a break in the math of either your curve or your surface, okay? This will make sense later on as I, explain the modeling principle of Alias more in depth. So, just to illustrate that point, okay, if I draw a curve, and I have just drawn a curve, and I need to describe an edge, a shape, I need more of a description, because if I just have a curve like this, it's kind of it's of limited utility, it's of limited use to us. We don't really have, we just can't really describe a whole lot with a 1 degree curve. So what we frequently do is we add degrees, okay, we add additional control points to increase the specificity of a curve, okay? So I've just selected 2 degree, and then we get this confirmation, these 2 buttons here. I'm going to hit accept on the bottom right, or you can hit the space bar. Okay, we're going to accept that. And then I'm just going to pop up the clutch menu here. I'm going to hit pick CV. This is with the left mouse button, Control Shift held down, and I'm just dragging the little elastic band here. I'm just dragging it over to pick CV, and I'm just going to pick the CV. Okay. So, and after I pick the CV, I'm going to hit Control Shift again, and I'm going to hit the middle mouse button this time. I'm going to hit move, okay? And right now I've just instructed the software that my intention is to move the CV in a direction, in an XYZ direction. What does XYZ direction mean? Well, it just means anywhere in 3D space. But because I'm working orthographically and I'm dragging the CV around, I'm only dragging it from the left view, from profile view. Okay, so I can't add depth to this curve. I can't move forward because I'm in the left view. If I wanted to move forward or add depth to this curve, I would have to switch out my view, okay, and then with the middle mouse button, okay, I would move it horizontally, or in the Y direction. You can see here in the Y direction, the Y axis, okay? So as a general rule of thumb, okay, the x-axis is the left mouse button, y-axis is the middle mouse button, and the z-axis, elevation, is the right mouse button, okay? Once we're done with that, we're going to hit Control Shift. We're going to bring up, we're going to press the left mouse button, and we're going to pick nothing, okay? That literally means to, disassociate your cursor or your selection from anything. Pick nothing. You're going to be using pick nothing a lot. You're going to be using pick nothing and delete history over here a lot. Okay, we'll get to that. Okay, I know you guys want to model cars and stuff, and you want to do some cool stuff in the software. I know this might be a little bit slow and a little bit basic, but trust me, this is very important. You need to know this. Okay, so we've just created a basic shape. Okay, I'm going to go ahead, I'm going to pick the curve. We have this basic shape here, okay? And you'll see that we know that it's a 2 degree curve, and like I said before, degrees, they mean, they indicate the level of control that we have over the curve, okay? So I can continue to add CVs as I see fit to give me the level of specificity that I require for a curve, for a shape, okay? And you might be saying, well, why does this matter? Like, why would I need to move these CVs around? Well, I'll tell you why it matters. It matters because not everything is a perfect circle or a perfect square or a perfect triangle, or things have characteristics. A lot of Alias and NURBs prides itself over the ability for you to represent or replicate organic objects in either the real world or a drawing or a photograph or something like that. So you really want to be able, if you're drawing an organic thing, something that that isn't really rational, okay, you really want to be able to represent that as best as you can, with as much precision as you can, okay? And this is an example. Well, this is a bit of an example of how other software packages might kind of miss the mark, because we have a superior level of control over the data we create, okay, over the forms that we can create and assess and evaluate compared to other parametric modelers. So this is really it's a blessing in its own right, okay? It really is a benefit of working with NURBs, that we can work this way. So here you could see I have this this original shape here. It's not rational or anything, it's just kind of hanging out there, and we've created, just by working in the XYZ axis in the 3D space, we've created a 4-degree curve with unique CV positioning, okay? So this illustrates how we can manipulate a curve using degrees, okay? Now I want to express something to you here. When we work with degrees, okay, and Alias in general, we always need to be mindful that less is more, okay? Less is more. We want our data to be light. We want it to be, we want to use the minimum number of control points we absolutely can, because in Alias and NURBs, things can get very complicated very fast. Data can get very complicated very fast. And if we start using an excessive number of degrees or more degrees than we really need, we will not only are we going to create a heavy model, but the functions that we use within the software are going to get bogged down. It's going to take longer for our system to make calculations. It's going to take longer for our systems to come to evaluate things. And we don't want that. We don't need that. We need to work as fast as we can. Well, not literally work as fast as we can, but we need to create models that can be assessed quickly and processed quickly. That's number one. Number two, frequently, and I'm sure many of you designers are familiar with this, all designers are familiar with this, is that if we create a model that's very intricate, that's very heavy, that has a lot of degrees and spans, it's going to be harder to edit. And we don't want that. It's going to be harder to edit, and it's going to take longer to rebuild certain things within the software, and you're going to waste time. So we don't want that. Now, I should also let you know, okay, that in the professional world, professional Alias modelers usually stay under about 5 degrees, okay? And there's a reason for that. I'll explain that later. It'll make more sense as we get on, as we learn more about the relationship between NURBs, curves, and surfaces. But for right now, just keep that in mind, that generally professionals stay under 5 degrees. Sometimes you might want to, add an extra degree. It depends on the situation. But as a general rule of thumb, a finalized Alias model should consist mostly of 5-degree surfaces and curves, okay? So that's degrees. Now, the maximum number of degrees we can use is 9, okay? Now, there really should be no reason for you to go this high, okay? Maybe if it's, in the beginning you're working fast and you're not being very precise and you want to get something out the door, that could work. But if you're working with curves and surfaces with 9 degrees and you need, this high number of degrees, there's something wrong. You gotta re-examine your technique here. So principally it's 5 and under, okay? 6 is kind of like yellow, borderline, and you don't really want to hit 7, 8, or 9, okay? And if you're generating surfaces and curves that are at 7, 8, or 9 degrees, you got to simplify. You got to rework your curves, you got to rework your surfaces, that sort of thing, okay? So let's bring it back down to 4, and now we're gonna bring it down to 4, and now let's talk a little bit about spans, okay? So spans, I would say they're a little controversial, and the reason for that, initially, remember I said that spans are basically a break in the math, either in a NURBs curve or a surface. And I would say, okay, so professionally, we always should strive for single span curves and surfaces. Finished, okay? However, a newer modeling technique, okay, is subdivision surfacing, okay? And it's great because it's fast. It allows us to work out an idea, on the screen without, really planning ahead or anything like that. It's good for that sort of thing because it's fast. The problem with subdivision surfacing is that it tends to generate heavy surfaces and an excess number of surfaces as well as we're modeling. So it creates heavy surfaces and an excess number of surfaces. And frequently these surfaces have more than one span, depending on how you're modeling, what it is you're modeling with the subdivision modeling technique. You might get more spans, you might get less spans, or you might get more surfaces, more patches, or less. It really depends, because with subdivision modeling, we get a product pretty fast, but the model becomes pretty heavy. The data becomes pretty heavy. And so what happens is that frequently we come up with a subdivision model with using subdivision surfaces, and we end up having to refine that model later on. We have to simplify that model, okay? Because it's just too heavy. It's too complex, it's too heavy, it's difficult to edit. The more professional, Class A modelers, I shouldn't say more professional. I mean, if you're working with NURBs, if you're working with NURBs, you're professional. But, for Class A modelers, Class A NURBs, Alias modelers, it's not nice. It's not nice. You gotta refine it. You gotta refine the work. Okay, a subdivision model needs to be refined to the Class A level. Okay, so just putting it out there. So that's the explanation of what a span is. And actually, what I'm going to do is I'm going to give you an example of what I mean when it comes to a spanned curve. So to give you an example of spans, so to speak, in action, or a situation in which a span could pop up, okay, What I'm going to do is I'm going to create a drafted surface, okay, that's going to be essentially extruded from this curve that we just built. So I'm just going to swing my cursor over, and I'm going to scroll down to the surfaces tab here. Okay, and by the way, I'm using the default layout. So many Alias modelers have a custom layout, a custom palette or palette, and that's cool and all. But you know what? I actually learned with the default layout, and I came to like where all the tools are located anyway. A lot of times you'll see some modelers with their own like separate palette, down here on the lower edge of the screen. I'm fine working this way. It works for me, so that's that. But anyway, and so I should mention that with every year that goes by, Autodesk likes to they add features, and frequently they tend to move tools around and stuff. And so some tools, the point I'm trying to make is that I'm making this tutorial now, and it could be that 2, 3, 4 years down the line, or maybe even 10 years down the line, the software is going to get revamped a little bit, and tools are going to get moved around. Okay, so bear in mind that just because you don't see the tool here in front of you when you open up the software doesn't mean that it doesn't exist in Alias. It's probably just in a different menu somewhere or hidden. So you can find it later on. There's a tool search. There's a way to search for the tool search. I believe it's under. Yeah, here we go. Tool locator. It's under help. So under the tool locator, you got this window here. So for instance, let's say for this video, I want the multi-surface draft tool here, right? But let's say it's changed. It's somewhere else. It's not under this menu anymore. So what we could do is under the help menu, we can go under the tool locator, and we could just off the top of our head type in MSD. That's weird. It should pop up. I don't know why. Okay, so if you type in draft, I guess if you type in literally, it won't pop up. So off the top of your head, that you want a drafted surface. So if you type in draft, and then there you go. You see MS draft or multi-surface draft, and it tells you where it's located in the palette. So you can either use a tool locator, or you can search over here. So anyway, we're gonna hit MS draft, okay, and then what we're gonna do is I'm gonna give you a better view here. All right, we're gonna click the curve, and what's happened is we see some information. We see these two arrows pointing upward, and we got this little gizmo, I think it's called, widget gizmo. It's popped up, and we see that we can click different parts of these dotted lines here. Okay, what we're gonna do, all we're gonna do is we're gonna click this dotted line. Okay, and what's gonna happen is Alias is going to extrude or pull a surface from this curve in this direction. So we got one half of the problem solved, but the second half of the problem is we need to define a length for this extrusion. Okay, obviously. So there's two ways we can do that. All right, we can do it from a technical aspect. Okay, we can type in 100 millimeters or 100 units of whatever, or we could do it visually. Oh, it's in millimeters. Okay, or we could do it visually. We could just drag it out. All right. So just to keep things simple, I don't want to get technical with you guys. Don't worry about this stuff. Don't worry. We're just going to drag this out, and I'm just going to hit the space bar to confirm that I'm happy with my settings, and I would like Alias, please build the surface. I hit the space bar, and we have this kind of like transparent rectangle that's just formed. Okay, so we've just created this extrusion here. Okay, and you'll see where my cursor is here. We have options in terms of how we shade our surfaces, okay, how we shade our surfaces. So, okay, we can, you know, I'm not going to go into too much detail with this. This is lighter stuff. I'll talk about this later, but you know, I'm just going to click, you know, the metal texture here, or maybe the light white clay. I'll just go to metal, and we are able to switch the shading of the surface by selecting it. Okay, so we see we have metal turned on, and I'm going to go ahead, I'm going to pick nothing. I'm going to hit Control Shift, left mouse button, up with the mouse, pick nothing. And if we hit Alt Shift and click with the left mouse button, we can rotate the model. Okay? If we hit Alt Shift and let me see here. Okay, if I hit Alt Shift and I click on a particular part of the model, I can set a pivot point for which the camera rotates on. Okay, so if I wanted to rotate on this corner here, this corner, occasionally this will get a little messed up sometimes. The whereabouts, the world, I would say, gets messed up, and sometimes we have to make some adjustments with our display. Don't concern yourself with that right now. It's really trivial stuff, at least in the beginning. So let's go ahead. We've picked nothing. We don't have any functions activated, and what we're going to do is we're going to select the surface directly, and we're going to learn a little bit about the surface we've just created. Okay, hit Control Shift, hold Control Shift, left mouse button, pick surface, and we just click on the surface. We just click like that. Okay, and we see on the right pane here, we see that we have one picked surface. It's a drafted surface. It's got 4 degrees going one way and 1 degree going in another way. Can you guess which way is which? Can you guess? Well, if you guessed that 4 degrees refers to this direction, okay, horizontally along the surface, and 1 degree, I'm sorry, I got it wrong. 4 degrees going vertically and 1 degree horizontally. If that was your answer, then you, my friend, are correct. Okay, 1 degree going this way, 4 degrees going that way. Why? Okay, why? Because Alias is software that's, or I should say NURBs. A NURBs model is information that's built upon relationships and associations. Okay, as above, so below. So if you create a curve with 4 degrees and you build a surface from that curve, you're going to get a surface with 4 degrees. If you have a curve with 9 degrees with a bunch of spans, and you build a surface based off of a curve with 9 degrees and a bunch of spans, you're gonna get a surface with 9 degrees and a bunch of spans. Okay, as above, so below. So we see this point in action here. Okay, now aesthetically, the way it is, it looks fine. I'm not going to evaluate the acceleration rate or anything like that of the surface. I'm not going to get into the technical aspects of surfacing just yet. I may never. It really depends on what you guys need and what you guys want to see. But for right now, just because we're being casual, I'm just giving this surface a once over. It looks pretty good. I can turn on the what's called zebra stripes. So these are zebra stripes, and zebra stripes helps us. It's funny. When I first started modeling, I used to use the stock vanilla stripes, the black and white. As I got a little bit better, I actually and so let me explain why we turn on zebra stripes. We turn on zebra stripes to assess the harmony of our surface with other surfaces, and to see how our surfaces are reflecting light. Okay, so this is a more technical way of looking at a surface and determining its aesthetic qualities. Okay, and the way we read the zebra stripes is that larger zebra stripes, okay, point to a larger, you know, if you imagine, you know, a light bulb in a room, okay, the black here that you're seeing here is basically a larger radius of light that's going to be reflected to your eye. Okay, conversely, tighter bands like these over here are going to be more sharp pinpoints of light reflecting back to your eye. Okay, but as I was saying before, when I first started learning Alias, I was using zebra stripes, you know, to evaluate my work. But then I started getting a little bit more sophisticated, and I switched over to rainbows. And I believe it's over here, and I would increase the repeats here to give me a better idea of what it is that I'm looking at. And I'd also, there was a way to, okay guys, I thought I was losing my mind there for a minute. I paused the video because I was looking for this particular shader, and I thought they may have gotten rid of it, and it turns out it was my fault. I was assessing the model with zebra stripes, but it's actually under ISO angle diagnostic shader, and under here it starts out initially, the default is single. If you hit this drop down menu, you can get down to rainbow, and what you could do is you can add, it's similar to the zebra stripes. The difference is that the light is not updated as you're rotating the model, and what you could do is you can add a bit of a blur to the zebra stripes, and that allows adding a blur to your zebra stripes in this way, okay, to your rainbow or to your ISO angle diagnostic shader. It gives you a little bit more of an honest, I would say more of a down-to-earth impression of the relationships that your surfaces are making towards one another. So that's the ISO angle, diagnostic shader, and these are the settings down here. Okay, but this is really advanced stuff. Don't concern yourself with this stuff just yet. You know, let's just go back to our old-fashioned aluminum foil metal here. Now, remember, the goal here is I wanted to create a NURBs curve in the wild organically. Okay, gonna go ahead, I'm gonna pick nothing, and we're gonna do this, we're gonna make an organic NURBs curve, or should I say, well, an organic NURBs curve in the wild. Okay, so what I'm doing now is I'm gonna go back to my curve button, my curve function here. I'm going to hit it with the left mouse button, and I'm going to take the Alt and the Control key. I'm going to press Alt and Control. When I do that, Alias is kind of like put on notice that I'm going to be referencing an edge, a curve, a surface, something in the vicinity of the cursor, and it's going to snap to it. It's going to lock to it. Okay, so I have Alt and Control held down, and I'm going to click along this edge, and as I click and I hold down the mouse button, I got the CV that's locked in this trajectory on the edge of the surface. Okay, and I'm going to drag this CV so that it snaps all the way. It doesn't actually snap, but it's going to just end up at this corner. Okay, the furthest most corner point area here. Okay, then I'm going to let go of the mouse button, and I'm going to do the same thing on the other side. I'm going to click the edge, and I'm going to go to this corner over here. Alright, then I'm going to let go. What did I just do? I just created another curve. It's a 1 degree curve, but it's not confirmed yet. I have to confirm it by pressing next curve or hitting the space bar. So I'm going to go ahead, I'm going to hit the space bar. Okay, I've just created this curve. Now I can create another curve if I want, but we're not doing that right now. What I'm going to do is, again, pick nothing, and when I pick nothing, okay, well, it still has that selected, but when I pick nothing, it lets the software know that I don't have any intention of doing anything else just yet. What I'm going to do is, I'm going to go under, what I'm going to do is I'm going to project this curve onto the surface, and I'll show you what I mean. Here we go. Surface edit, project, okay? So I'm going to click project. Now what does this tool do? What is this? What does this mean? Project? What is he doing? Projecting a curve on a surface? What does that mean? Okay, well, I'll tell you what it means, okay? I'll tell you what it means. The projection tool, okay, is a way for us to take an attribute of something that exists in 3D space and literally project these attributes onto something else. Okay, so typically we typically use the projection tool with curves and surfaces, but it's not limited to that. We could project. I won't get into the specifics, for this tutorial, but there's a variety of different objects that we can use to project the attributes of that object onto the subsequent surface. So the question is, why? Why do we need to project things? Well, we project things onto other things so that we can build relationships with those things. Okay? So, let's go ahead and go back to the software. So, to prove that point, so let's just say, for instance, okay, I wanted to make a curve on a surface because I want to build something, perpendicularly to this surface, let's just say, all right? I know it's a very random concept, but it's really, trust me, all of this makes sense as you become better with the software. As you progress with your knowledge of the software, all of this will make more and more sense, okay? So if we wanted to create a curve on a surface as a form of a reference, as a basis, okay, for something else, all right, we'd have to use the projection tool, and we'd have to project that curve or that object onto the surface so that we can create additional relationships, okay? So when we click this button, when we click project, we get this window that pops up here, all right? And we have some options available to us, and actually I think, all right, well, it's not a whole lot. And it asks us what we want to create, okay? We can create a curve on a surface, we can create a curve, and then there's a drop down here for vector, okay? It's fancy $10 word, vector options, and vector really, all it really means is a direction, okay? What direction, I should say, the vector is the direction that the tool is looking, okay, when it's in use, okay, when it creates the new information, it's the direction in which it's looking. So we can either make a projection from the view that we're looking at, okay, in which case, it's going to go, through, if you can just imagine your eyes, looking through the screen, okay, it's going to, that's the vector for the view. That would be the vector direction, okay, if view is selected. There's picked, so we can create a vector. Okay, obviously we have the button here, create a vector. We can retain a vector, we can refresh a vector. I've never had to use either of these. I've never had to anyway. We can project from the normal, and I use normal quite a lot. Or we could just back to basics, good old-fashioned X, Y, and Z, okay? We're going to pick normal. What does normal mean? Normal is basically perpendicular to the object in question. So for instance, if I were to just kind of show you guys, you know, in the real world here, you know, if we have a surface here and we have a curve here, okay, so let's just say this is a surface and this is a curve, okay, the normal vector, or the normal direction, would be the direction that's closest to the surface. That would be your projection. So what would happen is this curve would be projected perpendicularly to the surface in question. Okay? So what I'm going to do, it says up here, if you look at my cursor, it says select surface or projection vector. Okay, we've selected our vector, which is a normal. We're going to select our surface. Okay, and by doing this, we've indicated to the software that this surface is going to be receiving the projection. It's going to be receiving, you know, the best way to think about it is, imagine you have a piece of paper, okay, and the surface is going to be receiving ink from a printer head, okay, if that makes any sense. So the surface is the piece of paper, and the curve that we've just created is kind of like the ink, or it's kind of the, you know, we're going to be making an impression onto the piece of paper, onto the surface. So we've indicated that the surface is the piece of paper. We're going to hit go. Okay, we're going to hit the space bar, and then we're going to select the curve. All right, we're going to do, all right, we could just click the curve directly. I usually, you know, manually hit Control Shift, and then I select the curve, and I select it manually. Here, you know, we're just clicking the curve directly, and we're going to hit project. All right, with the normal vector turned on here. We're going to see what happens. Okay, so we have this. Okay, we have this. Now, why did this occur? Why did it draw it this way? Okay, well, if we look at it from the top, we could see that this curve, okay, is running nearly identical to this feature that we've just created. And this feature is called, this feature, it's not popping up over here, but this thing with the dots here is called a curve on a surface. So curves on surfaces, by themselves, curves on surfaces, they don't technically, I mean, they're of limited utility. A curve on a surface is really meant for modeling operations. It's really meant for you, the modeler, to work with, to manipulate, to generate other data. We can also use curves on surfaces to evaluate things. Okay, so to just illustrate that, well, I'll go ahead and I'll show you guys anyway. We have, for instance, we have a locator down here, curve curvature. Okay, if we select this, now if we select this, what happens is, if we select curve curvature, it's going to bring up an evaluator. Well, it's not really evaluating. It's going to show us how that particular portion of the surface is behaving from a curvature standpoint. And if we click it, okay, I just selected go, and I just clicked I just clicked the curve on surface. And if we click it and if we move around, we can see that we got this comb, this you know, these lines popped up here. Okay. And this locator is giving us information as to how this curve on surface is changing direction at the speed, and the speed at which it's changing direction. So we don't really need, it's not necessary when you're a beginner to know this, to know why it's important. Just know that that feature is there so we can really evaluate how, you know, our curves and our surfaces are behaving. Okay. So if we have locators popped up, if we have information about our work, you know, numbers and curvature combs and stuff, they're popped up on the screen and we don't want them anymore, because they can get in the way, they're distracting. We just hit Control Shift, we hold Control Shift, right mouse button, and then go to delete locators, and then it's gone. Okay, but remember, the point of this is I want to show you spans. Remember, the point of this is I want to show you spans, how they work in the wild. Okay, so let's say I wanted to build a curve off of this information. Okay, just a curve off this curve on surface. All right, the curve on surface by itself doesn't have any information. It's referring to prove that, okay, when we select the curve on surface, if I hit Control Shift and then pick COS, okay, it's not saying curve on surface. It's not saying that. It's referring to the MS. It's referring to the surface draft. So what we do is, if we wanted to create a curve on that curve on surface, if we wanted to match a curve to the curve on surface, we would go, I like to use this here, the fit curve. Okay, or we can use duplicate. Duplicate could work too. And I just want to check to see if I'm right. Let's see if duplicate works. Yeah, duplicate. That's interesting. Duplicate works. But we're gonna use fit curve, because fit curve, the fit curve tool is more precise, and I'm into precision. So, actually, you know what? No, let's work with the duplicate tool. We're gonna work with the duplicate tool. So the duplicate tool, what does it do? Gee, I wonder. It duplicates. Okay, the duplicate tool duplicates things, and it's typically used with curves. I don't think. Okay. Yeah, I don't think you can. It's typically used with curves. Okay. So if we click along, if we select the duplicate curve, just leave all the settings vanilla, default, and we click the curve on surface, and we hit go. Okay. I've just proved my point. Okay, I've just proved my point, because if we pick nothing and we turn on ghost mode here, okay, and if we hit Control Shift and then pick curve, Control Shift pick curve, because when we selected the duplicate tool and clicked the curve on surface, we've created a new CV curve. The system is matching a curve in a roundabout, relatively loose way to a curve on surface. Okay, so if we select the curve that we've just created, what do we see? Okay, we see that the system has created a 4-degree curve, and look at this, 5 spans. Why would Alias create a curve if we don't like spans? Why would Alias create a curve matched to a curve on surface with 5 spans? Why would it do that? I'll tell you why. It's a very simple reason. Alias is trying to match a curve as best as it's putting a priority on matching a curve as best as it can to the curve on surface, and it's placing the priority of matching a curve to the curve on surface more than it's placing a priority on having a relatively simple on the simplification of a curve. It's putting more of a priority on the precision of the curve as opposed to the simplification of a curve. Okay, so in this instance, what we have to do is we have to simplify it. Okay, so we can either simplify the work that we've just created, or okay, so before I talk about simplifying the work that we've just created, okay, this is just one example of dozens upon dozens, possibly even hundreds of situations that you're going to find yourself in when you model something in Alias. You're going to be working, you're going to see initially it's going to give you spans. And your job as a modeler, especially as a Class A modeler, is to keep this number down to 1 and keep this number as low as you possibly can. So we can either work this curve, okay, we can work with what we got and we can simplify it, or we can use a different tool, okay, to match. Now what I'm going to do is I'm going to delete this curve that I selected. So you can either delete it, you know, you could just press the delete key on your keyboard. You could just do that, okay. Another way is to another way to do it is by hitting Alt A, and you might be wondering, you know, why can't I just press the delete key? You know, I mean, why press Alt A when I can just press the delete key? And there's a good reason for that, okay? Professional modelers, you know, every second counts when we're modeling, and if we can avoid having to lift our hand up and move it across a keyboard or swing our cursor over to somewhere on the palette and physically like pressing a button, we work that way, okay? Because it becomes very tedious because we're always switching menus and switching functions and referring to different things within the software. It's just a lot easier, you know. I just hit Alt A and I call it a day. You know, that's a good way to remember it, you know, Alt A, call it a day. So anyway, going back to our curve on surface, there's another tool we can use that kind of consolidates everything, you know, kind of our intent, and that's the fit curve, okay? So within the fit curve, we have some options for greater precision over our work. Okay, if we refer back to the duplicate menu, you know, we do have a reduce span feature here, you know, but that's about it. Fit curve gives us greater precision. So with the fit curve tool, we see here we got some options available to us. Naturally, we want a one span curve, and we have degrees here. Now you could see that the fit curve, even the fit curve tool, doesn't really like going past like 7 degrees here. So this setting forces the fit curve tool to match a curve using a set number of degrees that you require. So we're just let's just keep it to default and see what happens, okay? So we see that there was a little bit of a process, you know, the system processed a little bit and produced a curve for us, okay? And we see that right off the bat, look, fit curve tool, it matched a curve, 3 degrees, 1 span, and look, we're only off by 200th of a millimeter, okay? So to get to really the Class A, to get to Class A construction tolerance, we'd have to get to 001, and we're not doing too bad. We're doing pretty good considering. So and that's with a 3 degree curve, okay? If we wanted to get closer to 001, we could add a degree, and that would give the tool greater specificity to match to the curve on surface. And we see we're getting closer. We're still just outside of tolerance here, 0018. Let's see what happens when we add 5. Okay, and here we go. 0009. So we're at you know, this is within construction tolerance. 001. We're just under construction tolerance. So now we've created this curve, fit curve to the curve on surface, using 5 degrees and 1 span. Okay, and this gives us a much cleaner way of generating data. All right, and to prove that, what I'm going to do is we're going to create another multi-surface draft. Okay, I'm going to swing my cursor over to the multi-surface draft tool. I'm going to click that, and I am going to click. I don't want this. I want the curve on surface. Now when you, okay, so what is it? I need to make sure that I'm clicking the curve on surface and not the curve itself. So let's see when I click. Okay. So when Alias doesn't know what you're clicking on, or when there's like a few things that are kind of bundled up together, Alias is gonna say, "Hey, did you want me to work with the curve or the fit curve? Which one was it?" And we're actually gonna work with and I wanted the curve on surface to be selected here. Where did it go? Alright guys, sorry about that. I accidentally deleted my surface and I had to recreate it, and then I just recreated the curve on surface here. So like I was saying before, if we decide to use the curve on surface, see, so Alias is going to ask for specificity. It's going to say, do you want the fit curve? Do you want us to build a surface with the fit curve, or do you want us to build a surface with the curve on surface, the COS that you created? Let's just go ahead and build a surface with a COS. This is a cardinal rule that you're not supposed to do, by the way. You're not supposed to build or make associations with curves on surfaces or trimmed edges, but we're gonna do it anyway because we're just learning and we're experimenting. We're gonna hit that. We're gonna go in the Z direction, and then we just hit build and see what happens. Okay, so we got a 3-span surface, and I'm pretty surprised that it's just 3 spans. I thought it would be more than that, considering if we hit Control Shift and then move the cursor to pick COS. Oh, you know why? I think I know what's going on. I think what happened was I accidentally projected the wrong curve. So I'm just gonna very quickly rebuild this. Let's just go ahead and alright. Why is it just 1 span? Okay guys, my mistake. Apparently I just re-projected the curve and I changed the projection vector to view, and then I went ahead and projected another curve on surface. This was my mistake. I was reading the object wrong, because there are a number of spans in this curve on surface, but the Alias is showing me the properties for the surface, not for the curve on surface. So that's why we're not seeing spans there. So I'm going to forge ahead here, and what we're going to do is we're going to build a multi-surface draft going in the vertical direction, and what we're going to see is we should see a number of spans emerge from that curve on surface. See, when we click MS Draft, it's going to ask us to specify draft surface curve on surface 1. We'll click that, and we're going to go up. We're going to click in the Z direction. We're going to hit build. All right, and we're still at, that's a low number. That's a very low number of spans. I wonder why that would be. Why it's such a low number, and we're hitting position too. Okay, well, maybe we're just getting lucky. It should be a higher number of spans, but maybe because the topology of the surface is so low, we're only getting 4 spans. So we'll go ahead, we'll delete the locators. Now, if you wanted to know what I just popped up, that's a continuity locator. We'll get to that in a bit. It's not necessary for right now. Let's just focus on what's in front of us. So we have here a 4-spanned surface. Okay, not terrible. It's not terrible. It's not the end of the world, but we don't want it. We don't want spans. We want 1 span. Okay, so what we can do to generate a cleaner surface is we can well, let's go ahead and we'll select the surface and let's delete it. Okay, is we can use the fit curve tool, select the fit curve tool. Let's see if we can reduce the number of degrees. No, okay, we'll stay at 5 degrees. We're under, we're meeting tolerance. We're very close. That's good. And what we're going to do is we're going to build a draft, multi-surface draft from that curve. We're going to select fit curve, not the curve on surface, the fit curve. Let's see what happens. We're going to build it, Z direction, and check it out. Okay, so initially, we have a new surface generated. It's a 5 degree surface, and it's one span. 5 degrees, one span. Okay, as opposed to if we were to build that same draft, okay, using the curve on surface, we build. It's a 5 degree surface with 4 spans. So just by having a clean curve, and this proves my point, just by having clean curvature or clean curves gives us clean surfaces. And that's what we like. That's what we want to see. So I'm going to go ahead now and I'm going to turn on my shaders. And we see here that we have two surfaces going into each other. And I'm going to cover in the next segment, I'm going to cover a bit about we're going to talk about relationships. I think this is a good segue into relationships and associations with Alias. And we're going to discuss, how objects can lead into each other and how we, we're going to get into the nitty gritty. I shouldn't say nitty gritty. The good stuff, the good part about NURBs and the beautiful things about NURBs. Okay, guys. So like I said, I think this is a good spot to kind of take a break, let things sink in, absorb. Because for the next segment, we're going to talk about relationships between different NURBs objects in the software. And this is really where NURBs shine. This is really like the beautiful aspect of NURBs and NURBs math. And it's totally necessary stuff because you're going to need to understand how to create relationships between NURBs objects to really create professional grade quality 3D models that meet the expectations for both manufacturing and aesthetic quality. And that really make people want to use the object that you're creating. So let's take a break and we'll get back to it.